All right, hello everybody, and welcome to the lecture for Chapter 1. All right, so we're going to go ahead and just get started with Chapter 1 this week. So, as you can see here, this is your textbook for the course, Exploring Research, 9th edition by Neil J. Salekind. I think it's a great textbook. The chapters are relatively short, easy to read. They provide good examples. The text will be important for you to read throughout the semester. It really complements what I'll be lecturing about on these PowerPoints. And doing both of these will prepare you for both the quizzes and the exams. All right, so this is just a really quick overview of the different things we'll be going over about Chapter 1. At the end of this PowerPoint lecture, you should be able to outline the research process, report on the different types of research and what makes research good, examine the scientific model, talk about the different steps that are part of it, and distinguish between different types of research methodologies, and then also illustrate the design cheat sheet. So what makes a good researcher? There are several characteristics of them. They find answers to important questions. They collect evidence. This evidence is then used by future researchers, and the evidence serves as a basis for decisions. An example of this basis for decisions, there's a lot of research on heart disease and diet, for example, and the research from this really influences interventions for healthier diets and cardiac rehab. So that's an example of how different types of evidence can serve for different decisions down the road. So what are the steps of becoming a researcher? There are several. Developing and understanding the research process, preparing to conduct your own research, learn how to judge the quality of previous research, not only this, but learning the value of that research, and then collecting relevant data about your own research interests. Obviously, there's much more to becoming a researcher, but these are some of the core foundations for what research really is. And we'll be getting into this in a lot more detail throughout the course of this semester. So one of the most important aspects of research is its relationship with theory. Research and theory are a little bit different, yet however they influence each other as well. We discover new knowledge with research, and theory helps us organize this new information. For example, let's say I wanted to learn a little bit more about student motivation, and I conduct research looking at what makes students succeed in college courses. I then find that students who are motivated by grades and mastering the content perform better than students who do not prefer to master course material, but are only interested in getting better grades. We can then use mastering goal-oriented motivation theories to organize what we found, and thus use these findings as well to implement them into the classroom and try to make students succeed much more. And this is actually these are actually results too from a 2005 study. That was a really interesting one. So what makes good research? We base our questions off of what previous researchers have already found. Going off of the previous example on student achievement in college courses, I would need to know what has already been found about this topic. I would have never known to examine student motivation and its influences on achievement if I had not read and been familiar with the previous literature. It's also important to kind of recognize the different holes in that literature and address those with my new questions. Our research also needs to be replicated and generalizable, which we'll be getting into in much more detail later this semester because this is a very important issue. In case you're curious, this is the issue of external validity, and you've probably seen lots of news stories about this issue in the news. So we'll get into this in a lot more detail later in the semester. Lastly, we cannot conduct research on a whim without any forethought. It needs to be based off of theory, and in this case, psychological theory. As you can maybe start to tell, there's really a cyclical relationship between research and theory. Research tends to influence theory, and theory then in turn influences research. It just keeps on going around and around. Speaking of a cyclical relationship, this is a graph kind of illustrating the research process. Over the next few slides, we'll go over each of these steps and also provide an example throughout to help illustrate this. As I stated in the Blackboard and syllabus video, my research expertise is the bidirectional relationships between sleep and marriage. So I'll be using a pretty simple example from that literature. And it's something I'm also interested in studying myself. So, first off, we need to ask the question, such as, how does sleep affect marital quality? After asking this, we need to then see what factors play a role in this question. Why do we think sleep would influence marriage? I then deep into the literature and I find that several factors that may influence this are marital communication and depression levels. So after I ask the question and find factors, I then move on to formulating hypothesis. An hypothesis is a statement that expresses a relationship between two variables. This is often described as an if-then statement. A good hypothesis sets out to test, not to prove, the alternative hypothesis. The null hypothesis is essentially no differences in your prediction, and the alternative hypothesis is making a predictive statement. Our hope is to reject the null and accept the alternative. However, it is not always bad if you cannot do this. Sometimes finding nothing just means that you need to ask your question in a different way and/or ask new ones. For our example, I would hypothesize that if a person has poor sleep, then their marital satisfaction may decrease. And that is my alternative hypothesis. What my null hypothesis would sound like is, I do not believe that poor sleep would influence marital satisfaction. After creating my hypothesis, I need to then collect the data to test this. I do this by creating a study. Again, much more detail on this later this semester. For example, I could bring married couples into a sleep lab and then the next day measure communication and their depressive symptoms. Alright, so after collecting the data, we need to run statistical tests to test our hypotheses. Yes, unfortunately, stats is a very important part of research, and again, later this semester, we'll dig into a little bit of introduction to statistics and psychology. We then need to examine and make judgments on this data. And in our example, we find that couples who have poor sleep communication, in our example, we find that couples who have poor sleep have poor communication and are more depressed. After this, we need to think real hard about what we found and how it aligns with the previous literature on this topic. It really depends on the nature of the literature and what we find about how this can go. Sometimes what we find really aligns with the literature and we add something new and exciting, or sometimes we just don't find anything exciting at all, and sometimes it goes completely against what the previous literature has found. These are some issues within research, and again, something we'll talk about in more detail later this semester. As I stated earlier, sometimes we do not find what we're hoping to find with our research, and it goes against our alternative hypothesis. What we can do then is maybe we missed a different factor. We need to look for some new factors by asking new questions about it. Let's say that we did not find any significant findings for our study on sleep and marriage. Well, maybe communication and depression isn't really important for marital satisfaction. Maybe poor sleep can also affect your diet, and having a poor diet can then lead to poor marital satisfaction or poor sleep. So we need to find different things that can influence this relationship. All right, we're going to just dip our toes into different types of experimental research. And again, last time I say this, we will be getting into this in much more detail later this semester. But I did want to introduce these right off in the first week so you can start thinking about your research proposal for the course. So non-experimental research simply describes the relationship between two or more variables. I want to note that it's very, very important to know that you cannot make any causal claims in this type of research. So one type of non-experimental research is descriptive research. And this describes the characteristics of an existing problem. Your book gave the example of the U.S. Census, which asks about different aspects of people living throughout the country. For example, one question they ask is how much your household makes per year, which plays into socioeconomic status. So this is just basically describing, it's being descriptive about how much each household makes per year. Another example of this would be me asking all of you what major and class standing you are. And then sampling from the 10 of you, I can then say how many of you are juniors, how many of you are seniors, how many of you are psychology majors, or how many of you have a different major that aren't psychology. So those are examples of descriptive research. Correlational research is another type of non-experimental, and it describes the degree to which two relationships are related. The strength of this relationship is given by the correlation coefficient, which ranges from -1 to 1. And the strength of this is really determined about how close it is to the absolute value of 1. So a perfect relationship would be a correlation coefficient of 1. A moderate relationship would be about a coefficient of 0.5 or -0.5. And what the negative means is that it's an inverse relationship, or also called a negative relationship. So if we have a negative correlation coefficient, this means that as one variable is increasing in value, the other is decreasing. So one example of this could be college partying and GPA. As level of partying goes up, GPA tends to go down. So that is an example of a negative correlation. An example of a positive correlation could be sleep quality and GPA. The more and better you sleep, the better your grades tend to be. I also want to note here a saying that you might have heard before, and it's something that you should definitely keep in mind because it is very important. Correlation does not prove causation. To go back to our examples I just gave, when saying that as partying levels go up and GPA goes down, that is not saying that partying causes a decrease in GPA. It's just saying that the two variables are related to each other. So the last type of non-experimental research we're going to talk about here is qualitative research. This also does not examine causation, and it looks at behavior in a natural context. A really common example of this is interviews or observing classrooms. Data for this is usually non-numerical, and researchers are really just interested in the content. For example, for interviews, qualitative research is looking at kind of the overall idea of what the interviewee is saying, not, for example, how many times they use the word or That would be more of a quantitative type of measure. So if you want to get into more what causes what, then we want to talk about experimental research. So there are two types of experimental research I want to talk about. The first one is true experimental research, which manipulates the independent variable, while quasi-experimental research has pre-assigned groups. So let's look at an example of coffee and talking speed. So I think you would hypothesize that the more coffee you drink, the faster you talk. So what you can do is you can bring people into a lab and have people drink coffee and then have them give a speech and then measure how many words per minute they say. This would be an example of a true experimental research design because we are manipulating how much coffee each person drinks. A really common way to do this is to split them into two different groups, where one group has no coffee and the other drinks 3 cups of coffee. You then compare the differences between the two groups and see which group talks more words per minute. Now, quasi-experimental research is just a little bit different. So with quasi-experimental, the group's already pre-assigned, and this occurs naturally. For example, gender is an example of a pre-assigned research condition. So going off the coffee and talking speed, we could also say, well, let's look at maybe just males and females talk faster or slower than the other. So we could bring females into a group and have them talk and measure their words per minute, or we can bring males into a lab and also measure their words per minute, and then compare the differences. This would be an example of quasi-experimental because the groups that we formed are naturally assigned. So selecting a method really depends on the question you're trying to answer. One way to kind of get an idea of what methods you should use for what types of question, this chart is really helpful. And I would refer to it throughout the semester as you are thinking about your research proposal. So this is just, again, a really brief overview of the different types of research design, and we'll be talking much more about them throughout the semester. Now, I think it's also important to talk quickly about basic versus applied research. These are the two main types of research that they're categorized into. And while basic research differs from applied a little bit, it's not very, very clear. So the main distinction is that basic research has no immediate application. And what this means is that if we find out something, there's no immediate real-world value for it. This may seem like a really odd distinction, especially since basic research almost always turns into applied. But this is sort of how it's been sorted out for a long time. And I just want to give a quick example to illustrate what I mean here. So let's say that we are neuroscientists and we are identifying different neurons in the brain. Just strictly identifying them, that is basic research because we're identifying them, but then we're not doing anything with that information. Applied research would be taking this new knowledge of what these different neurons and then using this knowledge to create pharmacological treatments for neurological disorders. So that's an example of how basic research can be turned into applied research. So just a quick summary of Chapter 1. Researchers have a passion to understand what they study. The process of discovering new knowledge is characterized as research. Theory helps us organize this new information. And there are steps to take in a research process. It's just the cyclical nature of it. It never ends. And there are two types of research design, non-experimental and experimental. And then these types of research can be categorized further into basic versus applied research. So this is Chapter 1. I just wanted to give a quick overview of kind of what the course is going to be about and what research is and the different types of design. If you have any questions about this content, please feel free to email me. You have a quiz on this due this week. The quiz will be about 60% material from Chapter 1 and 40% material from the syllabus. So please be sure to read the syllabus and listen to this and maybe go over your notes before taking the quiz. If you have any questions, please feel free to ask.